Okay, today we're going to talk about congruent triangles. This is Unit 4, Lesson 4. All right, so in general, what does congruent mean? It means same shape and same size. Okay, so for triangles to be congruent, what do you think that means? It means all the sides have to be congruent and all the angles have to be congruent. Those are all the pieces of a triangle. So in every pair of corresponding sides and angles are congruent, then the triangles are congruent. All right, in this example we have triangle ABC and triangle TON. So what do you think would be true about triangle ABC and TON if they are congruent? Well, if you look at the order in which these are written, actually when you write a congruent statement for triangle congruence, the order is important. The A being first and the T being first mean that angle A is congruent to angle T. And likewise, the B and the O mean that angle B is congruent to angle O. So it gives you the order of the corresponding parts that are congruent. And angle C and angle N must be congruent. Okay, so I'm marking with congruent signs for the angles. All right, in addition to that, we've got line segment BC must be congruent to line segment TO. So we can mark those up. And triangle BC must be congruent to ON. So here's BC and here's ON. So that makes sense, doesn't it? Those look like they would be the ones that are congruent. So we also have line segment AC and TN. So that is our third set of lines that are congruent. So we ended up with all the sides, AB, congruent to TO, and BC, congruent to ON, and AC, congruent to TN. All right, so that's three of the sides. What about the angles? That's the first part we did. We had angle A is congruent to angle T. Angle B is congruent to angle O. And angle C is congruent to angle N. So there are congruent statements for all the different pieces of those two triangles that are congruent. Okay, say you were given this set of congruent statements. Here are the angles that are congruent, and here are the segments that are congruent. How would you know what the name of the triangles are? Well, we've got all the vertices here with the angles, and we've got all of the sides here with these line segments. So, let's see, it looks like we're going to have triangle X, Y, Z. And remember I said that in congruence of triangles, when you state that two triangles are congruent, order does matter. So the corresponding angle, the one that's congruent to angle X, is angle P. So that must be congruent to triangle P, and the one that's congruent to angle Y is M, and the one congruent to angle Z is F. Okay, so now we've got our angles lined up. X is congruent to P, angle Y is congruent to angle M, angle Z is congruent to angle F. Let's make sure that we've got our segments set up. We've got XY congruent to PM, so that works. We've got YZ is congruent to MF, so that works. And we've got XZ is congruent to PF. So that works. So that's how you figure out what the name and the right order of your triangles are if they are congruent. So you have to have 6 congruent parts here. Every side and every angle. There's 3 sides and 3 angles. So if we have this triangle, triangle RUN, congruent to triangle SIT, I don't think run's congruent to SIT, but that's beside the point. So we have triangle RUN. So that must mean that angle R, we've got an angle R and an angle U and an angle N. So for our angles to be congruent, and they wrote it in this order, so that must mean that R must go with S, angle S, and that U must go with T, angle I, not T. Angle N must go with angle T. Okay? So there are all of our angles. Now let's write our line segment congruence. We have RU, segment RU, congruent to SI, the first 2 letters of our congruence statement. Then we've got UN, congruent to IT. UN, congruent to segment IT. And then finally we have segment RN is congruent to segment ST. And there are 6 congruent statements. So what do you think we could say? If 2 triangles are congruent, then all their corresponding parts must be congruent. Okay, do you think the converse is true? Well, that's kind of what we've been talking about. If all the parts of the triangle are congruent, then the triangles must be congruent. So yes, the converse is true. Okay, now let's look at what is meant by the included side, because we're going to start talking about angles, 2 angles, and what side is included. You'll see why in a few minutes. But let's just define that. Okay, so if we looked at angle J, this would be angle J. I'm doing in orange. Okay. These are the 2 sides of angle J in this triangle. Now angle N, I'm going to do in this blue, these are the 2 sides of angle N. Okay, so to find what we mean by the included side of 2 angles, between 2 angles, we'd look here at which side is included in both of the angles, the included side. So it's the one that has both the blue and the orange. So the side that's included in both J, in angle J and angle N, shouldn't be too surprised, is segment JN. Okay. Now, in addition to that, let's look at included angle. If you're talking about sides now, such as JA, so we've got this side, JA, and AN. So what angle is formed by those 2 sides? Well, hint, it's the one with the repeated letter. It's the one in between them. But it's not the definition of between, because these are not collinear points, right? But they do make up angle A. So when we talk about the included angle, this is what we're talking about. The angle that's included between 2 sides. So angle N is not included between these 2 sides. Okay? And if we talk about the included side, we're talking about the included side of two angles, a side that is between two angles. Okay. Let's start slow. Okay, well, it would be quite difficult and tedious to prove that every single side and every single angle are congruent when we wanted to prove that two triangles are congruent. So, do you think that there's a way that we could break that down? Well, there is. We have three postulate shortcuts. So, if you have, for instance, three sides congruent, all three sides are congruent, then the angles are going to be congruent, and therefore the triangles will be congruent. So if you have all three sides congruent, then the triangles are congruent, and that's all you have to prove is that all three sides. We'll abbreviate that a lot as side, 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 or SSS postulate. Okay, in addition to that, we also have a side angle side. So this is where our included angle comes into play. So if we have a side and the angle between them and the other side, if they are congruent, then the triangles are congruent. We will often call this side angle side, or SAS for short, side angle side. Okay, so back in our example here, we had side JA. If we were told that JA on this triangle were congruent to another corresponding side on another triangle, and AN were congruent, this one was congruent to another triangle and the corresponding side on that triangle, and that the included angle, angle A, was congruent to, again, another corresponding angle in another triangle, then we could say that those two triangles are congruent. Notice it's side, angle, side. If we had that instead of angle A was congruent to another angle on a triangle, if we had that angle N were congruent to another angle on another triangle, then we wouldn't be able to use side, angle, side, because we've got side, side, angle. We don't have this angle, side, side. Okay? So we have a third one, and that is the angle, side, angle postulate. So if two pairs of corresponding angles and their included side are congruent, then the triangles are congruent. And again, we abbreviate that quite a bit. Angle, side, angle. Okay, back to our picture. If we have two angles that are congruent, for instance, let's say that angle A is congruent to another corresponding angle in another triangle, and angle N is also congruent to another angle in a corresponding triangle, and AN was congruent to another side in the other triangle, then we would have angle, side, angle. Okay? But if we did not have AN congruent, for instance, we could not say that this was congruent to the other triangle, because we'd have angle, angle, side, instead of angle, side, angle. Okay, so make sure that you understand the included sides and these postulates. Okay, so using those three new postulates, let's see if we can figure out if these pairs of triangles are congruent to each other, and if so, which postulate we could use to show that. Well, in this first one, where we've got two sides here, this side's congruent to this side, and this side's congruent to this side. There's a third side that they both share right here. And if you remember the reflexive property of congruence, let's call that side A, just for demonstration purposes, then you know that A is congruent to itself by the reflexive property. So we can say that this one is congruent to itself. So now we've got side, side, side. So yes, those two triangles are congruent by side, side, side. Now let's look at this one. We've got two sides are congruent there and two sides are congruent there. We don't know anything about these sides, so let's look at our angles. Well, what kind of angles do we have here? Vertical angles, remember those? So we know that vertical angles are congruent. So now we have side, angle, side. So we can say, yes, these are congruent by side, angle, side. See, that angle is in between. It's included in these sides. Okay, now let's look at these two. Now we're given this angle is congruent to this angle. See the double hash marks indicating that these are the two congruent. This angle is congruent to this angle, and this side is congruent to this side. Well, this side is indeed between these two angles, so we can say that these two are congruent by angle, side, angle, since this side is included, the included side of these two angles. Okay, let's look at this one. Now we've got this side's congruent to this side, and this side's congruent to this side, and this angle's congruent to this angle. Can we say that those are congruent? Well, let's look. We've got side, side, angle. We don't have side, angle, side, do we? So these are not congruent. We cannot show that those are congruent. Okay, I'll let you take a look at these, see if you can figure out whether these are congruent or not, and tell me next time we're in class together. So you can pause if you want to look at those two. Okay, triangle congruence proofs. We're given that S is the midpoint of UT, here's UT, there's S. Angle U and angle T are right angles. Segment AU is congruent to segment NT. So for our first statements and reasons, of course, the first statement of every proof you ever write in your life is going to be the given. So state exactly what they tell you. S is the midpoint of UT. Okay? Angle U and angle T are right angles. And AU, segment AU, is congruent to segment NT. Okay? And the reason we can say that is because it was given to us. Now you might want to jump straight to the fact that these are 90 degrees, but you first have to say that they are right angles, because that's what they gave you. And you also might want to jump straight to the fact that US is congruent to ST because S is the midpoint, but first you have to state that it's the midpoint. That's what gives you the reason, the right to say that. So let's go ahead and do that. So since S is the midpoint of UT, we know that US is congruent to ST. Okay? And that is definition of midpoint. And let's go ahead and mark that on our figure. We can also mark this one since that one was given to us. So AU is congruent to NT. Okay, now let's look at the angles U and angle T. If angle U and angle T are right angles, then we know that their measure is equal to 90 degrees. So we can say that. Measure of angle U equals 90 degrees, and the measure of angle T equals 90 degrees. And the reason we can say that is the definition of a right angle. Now, if angle U is equal to 90 and measure of angle T is equal to 90, then by the transitive property, we can say that the measure of angle U equals the measure of angle T by the transitive property. And if the measure of two angles are equal, then we know that the angles are congruent. So if two angle measures are equal, then the angles are congruent. Okay, so let's mark that. Now if you look up here, we have side, angle, side, side, angle, side. So we can now say that triangle AUS is congruent to triangle NTS by the side, angle, side postulate. So we have proven what we want. Yay. Take a look at that. You will do lots of triangle proofs very soon. Okay, and that's the end of the lesson. Be ready to do the classwork that's written here as homework. See you soon.